Right, thanks everybody for joining today. Welcome to the JVM lunch. First of all, I'd just like to say thanks to our sponsors, RecWorks. They also involved with the London Java community, and they help by covering our meetup fees every month, so we really appreciate that. I suppose nothing much more to say other than to introduce Andres. So Andres first spoke at the Manchester Java community. We were just talking about this a minute ago. I think it's about 4 years ago in August 2017. And it was actually a virtual meetup like this, which was a bit of an experiment at the time, which obviously has now become pretty much the norm. But anyway, I'll hand over to Andres, let him introduce himself properly, and we can get into the talk.
Well, thank you very much, Nick. And it's a pleasure to be with you again, with everybody here, although virtually, of course, for reasons. And so you saw on the invitation that today the topic is going to be about Gradle. There's might be some Maven as well. So I'm pretty sure that most of you are familiar with both build tools, and there might be situations where you want to choose one over the other. And when you happen to choose Gradle and you're missing some of the stuff from Maven, then perhaps what you're going to see today will make your life a little bit easier. I'm going to share the screen if I click the right button first. And so share and then play the slides. All right. Before I really get into this, I will let you know that please feel free to stop me at any time if you have any questions. If you see me doing something crazy or something that was not well understood or whatever it is, let me know. Just raise your hand or unmute yourself and ask the question directly. That's fine. So crafting better Gradle builds with the Kordamp Gradle Plugin suite. So what is this thing? Well, first, my name is Andres Almiray, and I like working with open source. I'm currently employed by the Oracle, the database group, and there are plenty of things that we do inside the company that, well, the company is very well known by the database, but it so happens that it also has open source projects and open source products. So part of my job is to promote what's going out in that particular space and come back inside with the feedback that you guys can provide us so that we can make things better. So as you know, Java was released close to 26 years ago, May 23rd of 1995. And it was released at the time with one particular design choice, which was, let's use the C and C++ syntax so that developers will be able to jump from one platform to the other. Because of this reason, it proved to be very successful. And the build tools that we had at the time follow pretty much what we had in the C and C++ arena. That is basically make. Make was not really very portable compared to what the portability of Java offers. So a group of developers decided to create and you may have found this project across your career. I started with this back in, I think it was in the mid 2000 already when I was using Ant. And one of the things that I like about Ant is you could pretty much do whatever you want with your build. And that's the other bad side of the story, is that because you do whatever you want, every single build was custom. So jumping from one project to another pretty much signify copying the build file. And instead of pasting, or besides pasting, you would pray that it will work after all the modifications. So because that did not scale, that was really a nice thing to do. Developers decided to come together again and created Maven. And the first release was ready in 2002, if I'm not mistaken. And it gave us the convention of a configuration. It gave us a much stricter project structure. It gave us a project object module. It gave us many, many things. And for a while, it was good. But they were, again, after some time, a group of developers that saw that Maven was perhaps too restrictive. It was too constraining. And they decided to have more flexibility. And that's how Gradle came to be in late 2007, early 2008. And this is about the time where I myself decided to jump into this particular build tool for two reasons. Even though I was quite happy using Maven because of the features it provided, I was not very happy using XML because Gradle offered to use the Groovy DSL, and myself being a Groovy developer, I said, yeah, let's go with this one. And the other feature is that it seemed like getting all the benefits from Maven, the conventional configuration and dependency resolution and a few others, but it will also allow you to just hack on your build in case that you needed something. So try kind of like going back into the days of end. If there was something that couldn't be done because there was no plugin, or the plugin did not allow you to do what you needed, then that's not a problem. Just hack a little bit of Groovy code and boom, off you go. And sometimes you wouldn't even need a plugin to do what needed to be done for your build. Now, that was great because, again, your build tool will just bend to the will of your project instead of the other way around. The problem with this is that because you can write whatever you want without any restrictions whatsoever, every Gradle build was pretty much a custom build. So we're back to copying and praying. When you're moving from one project to the other, when you're moving from one organization to the other, your Gradle build will be completely different. You have to start pretty much from scratch. So after many years of working with Gradle, I just had one thought. What if we were to have a Maven-like structure on top of Gradle? Because we're talking about 2017, early 2008. I have plenty of experience working with Gradle. I had more than 400 Gradle projects out there in the open, posted on GitHub and whatnot. And every time there was a minor release or a major release of Gradle, things just will break down because the Gradle likes to break compatibility for various reasons. The point was that if I wanted to be onto the latest versions of Gradle and to have the latest and greatest features, that meant upgraded on my build scripts. And because everything was kind of like custom built and using custom scripts, then things were not working pretty well. At some point, I said, this is just too much work. There are too many projects. So is there a better way? And if we had a more constrained, more focused way to define our builds, something like a Maven-like structure, perhaps things will be better. And that's how I started this particular project in almost 3 years ago. And it all boils down to this feature coming from Maven. What is known as the POM is the Project Object Module. This is basically what defines what are the properties of a particular project, what is the structure, how we can mutate those properties, and when we can do so. Now, excuse me. So Maven delivers lots of features out of the box, thanks because of the hierarchical nature of the POM. This is another feature that is missing from Gradle. So yes, you can apply anything you want on the build. You can apply as many plugins as you want as needed. But if you want to reuse that kind of configuration, then there are a few avenues. You could put that into a script and then push it somewhere in your organization, or even you can put it on a GitHub repository, whatever it is, and they just consume it. But that will probably put you in a little bit of a bind when you need to do proper versioning and do reproducible builds and a few other things. So is there a better way? We'll have to figure it out. And there is another feature coming from Maven, which is known as the Maven Super POM. This is the one that allows Maven to provide lots of features out of the box for free. So basically, you define as little as possible in your own POM file, and you get the compile plugin, the jar, and sources, and Javadoc, and a few other things that you just work because it's there. Now, we don't have that really in Gradle. We have the building blocks. We got the basics to get to that stage, but we don't get it out of the box from core. And when I was asking people, why would they move from Maven to Gradle? Because Gradle is so great, Gradle gives you so many different benefits. Most people say it's because I don't want to hack on my build. And I'm quite happy with a fixed structure, something that is strict, something that will not allow me to deviate too much from a particular path. So that way, when I come back to my project many weeks later, and I need to make a change, then I can recognize where things are. If you were to do the same thing with a custom Gradle build, it will take you a little bit longer to get the job done, but you can certainly can do it. So what you want is to be more effective and do things faster. So the first thing I'm going to showcase with this idea of having something like POM and a Maven-like structure is exactly that. How do we structure our project? There are many ways. And I'm going to demonstrate 3 ways that I will recommend. There might be some others, but these ones will allow you to have certain benefits. The first one is the one, none of these names are actually sanctioned by anybody other than myself. There's nothing from Gradle or Maven. It's just decided to call this the standard way. Why? Because most people have the topmost build file and then sub-projects at the adjacent directories. And there you go. Whether this will be POM XML or build.gradle is up to you. One thing that I like about Gradle is that you can change the conventions. And the convention for the build file is that it has to be build.gradle. If you're using the Kotlin DSL, it has to be build.gradle.kts. But what if you were to change the name of the build file to match the name of the project? If you're using an IDE, then this doesn't affect you too much, I say, because the name of the project will become the name of the tab of the editor that you see in the IDE. If you use if you don't use an IDE, if you're like myself, you use VI or Vim or any other text editor, then these tabs do not have the proper name. So if we ever to rename the projects, the project build files, then that can give you a hint if you are modifying the right build file. So whether you go with build.gradle or guide.gradle or following the project name, it's up to you, but this will be the standard file structure. The next one is a 2-level structure where projects that have certain commonalities are bunched together into the same subdirectory. So now we can see project 1 and project 2 belong to or may have the same or similar capabilities. So they're put together in the sub-projects directory. Inside the docs directory, we'll find guide, there may be manual, there may be Java doc, there may be tutorials, whatever it is. So, and you can do exactly what you want as long as you have a 2-level structure. Notice that again, you can do build.gradle or you can use the project name.gradle. And finally, there's a mix of the two where you want to have projects at the first level, at the second level, or at the nth level. So that we call that the multi-project level structure. Now, if you were to do this, to follow any of these structures with Gradle, you had to add additional code into settings.gradle so that the name of the project is taken into account if you want to use that, that all the projects following the particular path will also be included. Now, if as your project grows, if you have many projects, then of course you're going to see a lot of lines of code in your settings file. It will be much better that if you are following a certain convention, then the project build should also follow that convention so that what you configure in your settings file is smaller. And that's one of the things that we're going to see provided by this. Next thing is the POM or something that looks like a POM, a DSL that allows you to define common information that can be harvested or can be harnessed by different plugins. When you look at the Maven POM file, the project URL, the name, the license, SCM, developers, contributors, dependency, plugin management, dependency management, all those blocks can be reused by other plugins to do whatever needs to be done. So that information is reused by reporting, that information is used by testing and Jacoco and so many other things. So that's the advantage of putting everything in one place. Gradle out of the box does not offer this. There are a couple of plugins across the different history of the plugin ecosystem in Gradle that have tried to do this with some levels of success. So Kordamp is the latest one that tries to do this. So let me show you what the DSL looks like. And don't worry, we're going to get into code and make this thing try to be more interactive. The latest version of the plugin, or actually the latest version of the suite, because there are more than 40, I think there are close to 44 or 45 plugins right now, is version 0440. There have been 51 releases so far since October 2018. And what we're seeing here is something that looks like a POM file, but of course, it's a Gradle build file. The config block is what we use to define the configuration for our project. And the first block that we see here is the info block. This is the one that provides pretty much a one-to-one mapping to the elements that you find upon. So there's the name, there's vendor, description, URL, organization if you need it. There is a set of links that may be reused by the generation of the POM file. If you happen to use the bin tray plugin for publication, then these links will also be reused when published into bin tray. And then there's a list of people for which you may have a developer role that will be mapped to developers in the POM file, or you can have the contributor role, which will be mapped to the contributors block in the POM file, or you can have as many roles as you want, and you can add as many properties as needed. Again, a plugin will be able to consume this information and figure out what needs to be done. And there are other elements in the DSL that allows you to control how you want to generate documentation and testing and generating additional artifacts and publication, and we see those in a moment. Another thing that I like about Gradle itself is that there's plenty of information that you can harness from your build. It's just that it's not really exposed on the command line. But what if it was possible? So what Kordamp does, at least the base plugin does, is gives you additional tasks to find more information about your build. And if you want to know what are the names of the configurations, because configurations are like Maven scopes, but they have more information, of course, then this will list all the configurations. You can list all the plugins or extensions. You can list the sources or repositories or publications and the projects, the project properties, and we'll see that. And perhaps the one that is most important from the list will be effective settings that says display result settings for projects. What effective settings does is reads all the information that you put into the DSL and print it out, just like effective POM does in Maven to give you everything that Maven is going to be doing for your particular build. So here I have a list of some of the features that this thing gives you. So you can configure projects by type. So you can configure a generic project, or you can explicitly configure Java, Groovy, Kotlin, or Scala projects. So this will add additional features on top of these languages. You can configure artifacts and publishing, so that will configure the jar plugin for adding or enriching the manifest with additional properties, generating the source jar, generating Javadoc jar, generating an additional POM file that gets injected into the jar, and of course, everything that needs to be done with publishing if you want to publish to a Maven compatible repository. You can configure license checks so that you can download all the licenses for your dependencies and aggregate for that as well. You can configure how you want the license headers to be formatted for the files with different rules. And you can generate statistics about your sources to get a count of how many lines for Java, Groovy, Kotlin, Scala, JavaScript, and so many other things that are supported. And you can get an aggregate as well. In terms of documentation, well, there are additional settings that can be configured for the Javadoc, GroovyDoc, KotlinDoc that uses Docker, ScalaDoc. If you want to have a prettified version of your sources in HTML that's using the plugin called Java 2 HTML, well, that's actually source HTML there. Or if you're familiar with the XREF documentation generated by Maven, at least for Java sources, well, source XREF will give you that. And those all work for single projects, but if you are at the root and you want to aggregate everything together, then they also work at the root level. In terms of code quality, well, we add additional capabilities for checkstyle, codenart, CPD, detect for Kotlin, error-prone, PMD, and Spotbox, also SonarQube. Wherever any of these small plugins or project-specific plugins provide these readings and measurements, they can probably be published to SonarQube as well. And if you haven't picked up at the theme now, is that this thing not only configures plugins for a specific project, they also configure aggregates at the root level. And finally, in terms of testing, there are additional information that can be put out in the console when you're running test cases in case that you want to have a look directly in the console instead of looking at the reports. There's automatic configuration for integration and functional test cases with additional test source sets and the everything on the class paths that are needed for the IDE and the build tool to find everything. There is code coverage with Jacoco and aggregates again. And if you want to publish this to the wild and have a historical records of code coverage, then there's a coveralls plugin right there. Okay, so that's a bunch of features. Now let's see this thing in action. So I'm gonna stop sharing the slides and let's go with this particular project. Right, so this has a settings file and a build file. This is just a single project. And we have a look at the settings here. This is pretty much a standard Gradle. There are many ways for you to define plugins, and one of them is to define them in the settings file using the plugins management. This is quite similar to the plugin management block that you find in Maven. And here you define the plugin IDs and the plugin versions that you may use in your build. That does not mean that you will use all of them, or you can actually define in which projects you want to apply these particular plugins. An additional benefit of defining plugins in this way is that you can either define the version ID directly as a string, or you can use a variable coming from properties. This is not possible if you define the plugins block in build fast. You can only do this in settings file, at least in version 6. I don't know if that's going to be changed in future versions of Gradle. And notice that this does not make any use of settings. The only thing that it is saying is I'm going to apply the Java project plugin and a few others. That's it. Let's look at the build file. It applies a few of the plugins. Actually, that's when we actually apply the plugins, and then it creates a couple of properties if values are not defined, and then actually makes use of the POM DSL, which is very similar to what we saw before. So it is at the beginning, it's just kind of like information pertaining to your particular project. So name, vendor, description, inception year, links, people with roles, implementation, credentials, blah, blah, blah. Then we have a few other blocks that we didn't see before, like the licensing block. You can have as many licenses as you want. There are a set of predefined licenses that are SPDX compatible. If none of those licenses are suitable for you, then you can define the name, the URL, and any other properties. Otherwise, you can just use the ID for those predefined values, and then you get plenty of information. You want to come to publish to Bintrade. Sadly, Bintrade is going away May 1st, but until that date, we can still publish to Bintrade. So that's as easy as it's done. And we configure some Java docs. And finally, just regular dependencies, and the rest is just regular Gradle. There's nothing to it. Now, let me show you some things about that inside. So I'm going to run effective settings for this project. Oh, should probably do it for the root, because there's a multi-project build. And here we go. There we go. So for the root project, we got these properties. The inception year was defined in the build, but notice that the build automatically computed, well, I'm going to use this as the copyright year on all my headers. This information is available in the build, so that's fine. What else do we see here? All these blocks that we didn't see before, issue management, CI management, mailing lists are also enabled, but they contain no information whatsoever right now. And the passwords get automatically obscure, so they will never get printed out unless you want to. There's a flag for that. And here we start to see additional bits. If you want to enrich your jar files with information pertaining to your build, this is the information that will be added to it. Now, I find this information quite useful when someone says, I encounter a problem with your project, and I'm using version such and such. And if you tell them to look into the manifest, or your project knows a way to grab that information from the manifest and print it in some log file, then you can actually tell that they have the right version because it was built at the right time and it was built using the right commit hash. If that information does not match, that means that they probably using a version that they built themselves or they obtained from some other source that is not the one that you want. More information about the jars. Yeah, building a jar is enabled, and there is no additional information coming from the manifest. The min pom is enabled. We'll see what this thing is doing in a moment. And generating a source jar is also enabled. And generating an aggregate source jar is also enabled. Configuration for bin tray is taking some of the information coming again from the build DSL. Publishing, this is the only thing that we're going to publish right now. Notice that in terms of licensing, it has more information regarding the Apache 2 license that we define just by an ID. In terms of Java docs, this is everything that are the default settings, but there are more settings that can be obtained or derived from your build settings. For source HTML, there's more information like that. Then these things for coverage, in case that we want to generate aggregates in a multi-project build, and coverage is enabled by default. And then we get into the testing block, for which if we were to have integration and functional test cases, these will be the source sets, and generating statistics. Okay, so what else do we have here? Well, let's have a look. How many plugins? Or which plugins do we have? Let's do this on the root. Let's see. Oh, typo. Plugins. There we go. We get 41 plugins, as a matter of fact, because we start counting by 0, right? There are plugins that are coming standard from Gradle, standard from Core, and at some point we will see the first Kordamp plugin, which is enabled. We can enable and disable plugins per project, and that will give you more benefits or more behavior or less behavior depending on what you want. And well, you can have a list of all the different plugins that are applied. We can also have a look at all the extensions. I think there are like more than 10 extensions defined by default, actually 19 extensions. Okay, good. We can also have a list of all the configurations, if I'm not mistaken. And 29 configurations, and you can ask settings for each one of these configurations to know what's going on. We can have a look at, what is it? The publications. What publications will say? Well, there is a main publication, which is type of Maven. I'm going to use this group ID, artifact ID, and version, and these are the files that are associated with that particular publication. Okay, and here's another one. Did you ever have any problems with figuring out what is the compiled class path? Or maybe there's some issue with the compilation step? No, so there are a few things that we can do. I think we do, let's do tasks with group insight. For some reason, I can't recall exactly what's the name of the task that I want to invoke. And the one that I want to invoke is this one, Java compiler settings. So just copy that one and invoke that task. And it will tell me for compiling my production codes, there are the default settings that I have. And for compiling test codes, this is what I have. But there's another thing that I can do, is that I can grab the name of this task and say something like this: compile Java and append task settings. Let's see what I have. This prints out all the possibilities for all the variables, or all the properties for this particular task. So there are a bunch that are internal that there's no point in, or there's no point in going into further details. But I can tell now that what is the class path for this particular task. So I know that it's going to be just production code on SLF4J. I know that the task is enabled. I know what are the sources for this particular compilation task. And the outputs, I think, will also visible somewhere there. This is not currently being printed in extended mode, will be done in the next release. And you can do this for pretty much any task that you want to just add task settings. And we could go on and on and on with the settings, but I want to show you something. I'm going to do, yes, and do a clean because I built this before. Going to build, and I'm going to publish locally. And I'm not going to use the build cache so that I actually see everything that is going to happen here. Let's see. Configures, applies license, everything is fine, generates the Java doc, and now the testing. This is one additional thing that the plugin does, is that if you want to know how many test cases were executed, successful, failure, skipped, how much time the whole test case took, then you can see it right there in the console. If these colors are not the right for you, you can change them as well. You can change to, I think there are 8 different colors that you can choose from in case that these are not suitable for you. Well, we also see how many were executed instead of just going directly into the generated HTML report. If any of these were to fail, then this icon will be red, it will be an X, it will be a cross, and of course we will see a number changing here, right? Another thing that we can do here, what else can we do here? Let's move into a multi-project build. Let's go into another project, like the JWard project. This looks like this. It has a build file, settings file, has projects in plugins, and has projects in docs. So this is a 2-stage or 2-level project. In this case, I do have some changes in settings. It looks like this. So some plugins that will be applied, and then there is a plugin that is applied to the settings itself. And this is the one that allows you to follow the conventions. I think I may have another project that makes it more explicit, like this. Here we go. The settings plugin. So remember about the standard, the 2-level or the multi-level layout for organizing your projects. Well, this particular plugin knows exactly what will be the conventions. So you can simply say, I want to include everything from docs, from core and plugins. And if the directories inside follow the conventions, then everything should work out. So let's look at docs. We have guide, and guide has guide.gradle. If we look at core, there are enforcer API and rules. And we look at enforcer API, there is enforcer API.gradle, and rules has enforcer rules.gradle as well. So they follow the convention. Good. What else can we do here? Now that we're having a multi-project build, I can say from standard Gradle, list the projects, and we get this in just a second. I don't know why it's taking so long. So we get this information, just the names. But if I use list projects coming from Kordamp, then we get this. Not just the names, but the paths to the files and where these things are going to be added. So these are standard properties from the project. Did you notice this here? This is another thing that Maven does. It provides a summary report of the execution of your project. So what if you do a clean and classes on this build. Should invoke clean and classes for all matching projects in my multi-project build. I'm reusing the cache to make things a bit faster. And I get this nice report. This is the amount of time that it took for each project to be configured during the configuration phase. And this is the amount of time in wall clock time that it took for all the tasks that were related to this project to be executed. There is an additional setting that you can define for this report so that you can see all the different tasks based on their state. If it was invoked, if it was cached, it was failed, if it was skipped, if it had sources, if it came from, if it was actionable, and there are like 3 other states that you can query. And you will notice that this number right now matches 5 and 5. But if you have a much larger build and you're only executing a subset of the build, then this number will be smaller, of course. It will be, this is the total number of projects that belong to your build. And these are the total number of projects that did execute some task. Okay. So what else can we see here? Let's move into the Kordamp projects itself. This build also has some projects, some plugins like that, and now has an additional DSL here. There are many ways, again, that I said that you can apply plugins using the standard Gradle conventions. What this thing is telling me here is that all these projects for which I'm using the long notation, so that is the class path notation instead of just using the ID, I'm going to match all the projects that I have using these blocks, the all block, path block, and their block. And what this thing is saying is, for all projects, apply the idea plugin. Okay, that's fine. For the root project, apply Groovy and Bintray. For the guide project, I want to apply guide and publish. And for everything that is inside plugins, I don't know how many projects I have, but anything that matches inside the plugins directory, I want to have these 3 plugins. So what is the change here? I could have Groovy project set on the root. That's not a problem. I could have the guide project set on my guide project as well. That's not a problem. But if I want to change how all my plugins projects are built with the different plugins, then I'll have to go into every single build file to change that. But with these matchers, then I can do all of them in one go. So in the end, if I look at the root file, there is no plugin configuration. If I look at the guide, there is no plugin configuration either. And if I were to look into any of those plugins, like this, I only have dependencies and additional configuration for tasks, in this case, process resources. So this means that if I follow my own conventions, then your build files will be much, much simpler. In my case, just defining dependencies. What else can I show you? There is a bunch of directories here for a lot of plugins. But if I just want to build one of those, say this one, the base, I could do base Gradle plugin and then just classes, something like this. But typing base Gradle plugin is a lot. One thing that I can do also is this. Build everything that matches base. Now, I do know that Gradle, I think sometime in Gradle 6 offers a feature that can expand the name of a project. So if it's unique, I think that we can type something like, in my case, will be lowercase b and then capital GP. So this will be the same as this, BGP. I think BA has to be done because otherwise it will probably match another project with B. Let's see if this is actually true. Yep, it's kind of working. So I added this feature because I was not aware that they also added this particular feature later. Another thing that I can do, this is something that I like about Maven, that you can invoke any plugin from any build without having to change the build file. How does that work? There is a plugin configured out there called Echo that is not configured in this build. I can use the full notation, which will be Echo Gradle Plugin version 44.0. The task that I want to invoke is Echo, and the property I want to pass in is Echo message. Hello, Manchester. Sure. Oh. Right? So I could do this. But given that, like Maven, it can also resolve what is the latest version, so I can do that. And I can also do this, I believe, with just the ID of the plugin. Given that this is a multi-project build, it's going to probably invoke it for everybody. So what I'm going to do is move into a single project build again and invoke that. And let's see what happens. And this is Java user group. Oh, this doesn't have the inline plugin. So I'll let you know why this doesn't work. I need a project that has inline. Okay, let's go back to Kordamp where we were. Because this feature is not enabled by default. And here we go. Hello, Manchester Java user group. And what is going on with this? Well, there is a plugin called inline. Where are you? This one. That allows you to invoke any Gradle project, any Gradle plugin in these ways. So you can use the long notation as I was trying to showcase, or you can go all the way to the show notation. And depending on how your plugin is published, then you can use one of the others. There's actually some support for core plugins so that, say, we can invoke the application plugin like this, which is very similar to what you can do with Maven during exec Java and then pass exec main class to the project. Right. Coincidentally, this is documentation for the project, which is built with the project itself. So this is the output of the guide plugin based on the project. And you can see there are 44 different plugins that belong to the suite, give you all the different capabilities for this particular set of projects. Okay. There's one last thing that I want to showcase, which is as good as bad this particular plugin suite is, the advantage is that it gives you common behavior that you can apply to your projects. And if that common behavior works for one project, that's good. But if you want to share it with other projects, then we get back into the problem of there is no parent POM support in Gradle. But what we have are, again, plugins, and plugins are the key to make this happen. What if we were to create a plugin project that functions as if it were a parent POM? Well, I have something like that, and it's just a regular plugin. So say this is a plugin that will apply the settings that we saw before. So it will apply Java project and define some properties, and then use the config block to define some basic information about that particular project, define credentials, some basic repositories. My projects will always be Apache unless I say something differently, configure Javadoc, Bintray, I know it's going to go away, but it's still defined there. And we'll configure the manifest and some additional rules and source compatibility. Great. So now, for every project for which I want to use my conventions, I need to apply this plugin. There is also in Maven the super POM, which says every single project that you build with Maven is going to inherit certain behavior. Can we have that in Gradle? Yes, we can. It's again another plugin. But instead of applying to a project, you apply to the settings. So this is why I have this other project. It's called the parent build plugin, for which it applies settings, which is the one that defines how to work with the structure. It applies inline so that I can resolve plugins on the go. It applies insight, which is the one that gives you the output of the execution for all the projects. And applies the enforcer plugin because I am quite pedantic of how I like my projects. And it does some configuration for those plugins, but most importantly, and this is one of the things that I like about the settings file, is that after all the projects have been loaded by Gradle, I'm going to apply to the root project the POM plugin that I just defined. This means every single project that applies the Kordamp build will have these basic settings, and automatically everything that is built in this way. Thus, if I show you the build for Enforcer, which is something that I have, no, actually, let's show you another build here, this one. This is the build for a plugin that follows those conventions. It applies the parent build, and it does nothing else. And if I do follow my conventions, that is, I put documentation in guide and put it in docs, and I follow as many projects I want in plugins or sub-projects. And if I either choose build.gradle or the name of the project matching the directory, then I get a lot of things. The root file looks like this. There is little configuration that needs to be done in terms of information, because most of it is going to come from the parent. There is additional information that I had to put in this project regarding documentation because it's a Groovy project, it's not a Javadoc project. The plugin itself applies additional plugins. I decided to do this explicitly instead of putting it in settings, as I showed you in Kordamp. Then configures the plugins block that is specific to this project, because not everything else is a plugin here. Dependencies, and that's it. So that once we put this together and go back to this plugin and say, give me the effective settings for the root, and only give me the sections for info right now, then this will print out this information. You might remember all this came from the parent. Same as this, it's just based on the conventions. And there's nothing more that I need to do. So my build turns out to be much, much simpler. All right. So I guess that was pretty much it in terms of features. And there are more features that I could show you. And in case that you have any questions, let me know. The project lives at Kordamp Gradle Plugins. That's where you can find the guide. And it's also found on GitHub, where you can look at the code. And if you have any feedback, well, I will certainly encourage you to file a ticket. There is a blog post, the third link, that explains the reasoning behind creating these projects and how these things came to be. And if you were paying attention, I was never invoking the Gradle command directly. I was using a Gradle wrapper called gum, which allows me to invoke Gradle from anywhere within my project, or invoke the wrapper or Gradle itself, depending on how I have things configured. So everything we saw today is open source, and if you have not contributed to open source before, it's quite easy. If you have any trouble with any open source project that you consume on your daily work, just file a ticket. That's it. There's nothing else that you need to be doing. If you have the time and the passion, certainly provide some test case and patches if you want to, but at the very least, just filing a ticket is plenty of help already. So I guess now I open the floor for any questions that you may have.
Great, thank you, Andres. It was a really interesting tour of the plugin suite. We've got any questions from anyone?
Hi, I've got a question.
Cool.
I'm only starting out in programming. Do you think it's a benefit or a boon that we have so many build tools for Java? Like in other languages, they have like a default build tool that you just use. You don't have to worry about learning Ant or Gradle or Maven or.
One of the things that I find great about the Java community itself and the Java ecosystem is that we have choices. And the evolution of these different build tools showcase where at the time developers were thinking. So one of the things that we can see about Maven is that it uses XML as a DSL, because when it was created, when it was born 18 years ago, XML was the rage. When Gradle was born 13 years ago, the developers were already moving into DSL, and there was this huge discussion whether you should write internal DSLs or external DSLs, and combination passes. Is Scala the best thing or is not? And so many things, and that's how we got the next batch of build tools. Maven is quite straightforward and is much older. Gradle is focused on performance, and depending on the things that they do, you will find some of the issues easier to grasp, some of the features easier to understand, and some others not. Regarding with the other communities, JavaScript has the same problem. They have so many package managers, they have so many different build tools, and so many web frameworks. There's the joke that there is a new web framework in JavaScript coming out every single week. And for sometimes that's a good thing, because you need that kind of evolution. And sometimes like, oh, and now I need to learn another thing. As a newcomer to the Java community, my recommendation would be, I actually right now, I wouldn't be able to tell if I would recommend you to start with Maven or to start with Gradle. I would say try both, because both of them have certain benefits that the other does not offer. Maven is perhaps the one that is most known by many out there, by many developers. So if you were to join a team or some company, it's most likely that you are going to encounter Maven first. There may be other teams where you find Gradle. I would again definitely recommend you to give it a try, but perhaps not at first. It gives you some sort of there's a way that you can find the differences and the migration path within one build tool and the other. I know that that's some kind of answer to your question.
Yeah, it has. I mean, I've tried all three of them, and I definitely prefer Maven. I'm not really a fan of having to debug another language just for a build tool. I know people don't really like XML anymore, but I still really like it. And for the other build tools, I meant more like the Rust community, where they've standardized on Cargo, which is a really nice, solid build tool. And it means that if I want to contribute to a Rust open source project, I just need to know Cargo. But like at the moment, if I want to contribute to Spring, that means I've got to go and learn
Yes.
Whereas a lot of the other stuff that I'm interested in is already using Maven. So it sort of steers me to wanting to help with those projects rather than something that's using Gradle, if that makes sense.
Right, no, completely makes sense. And specifically in Spring, they migrated to Gradle just last year ago, at least Spring Boot. There are still a bunch of Spring projects that are remaining in Maven, like Spring Data. And there's a mix, even in Red Hat, there are mostly Maven builds, but Hibernate is built with Gradle. So the reality is, as our Java developers, that we kind of have to understand how to work with both build tools. We not necessarily have to become experts on each build tool. It's perhaps easier to get acquainted with Maven much faster than do it with Gradle. Reason being, every Gradle build is custom.
Yeah, I think that's my problem with it.
Right, which is why I built these plugins to be able to recognize a build structure once you go. If you had a look at the different projects that I showed, all of them use the DSL, and some of them use the parent build feature, and some others didn't. So the code is a little bit longer in terms of descriptions, but the actual behavior is exactly the same.
Yeah, I really like the idea of because that is something from Maven, the idea of the parent POM. It's nice to kind of be able to share that behavior across projects, and especially I've seen in my organization, every Gradle project, it goes its own way in different ways, and actually having that commonality across an organization is just something that is missing, really. So this is it does kind of fit that bill quite nicely. So I suppose my kind of question that I'd ask then is how popular have you found Kordamp to be? Because obviously it's solving a problem, which is a really kind of good problem to solve. But the real benefit comes from, I suppose, how wide you see this being applied, I suppose, across different ecosystems, organizations. Do you have stats around that?
Right. So the project is, again, I said that it was born around October 2018. That's when I did the first commit. And they did it based on the experiences that I have the 10 years prior building my own projects. I put everything in a plugin, which I should have done earlier perhaps, but I'm happy that I finally did it. And since then, we have crossed the line of 450 different issues. I have filed most of them because I consume my own things. I want to make things better. And I do have, there are issues filed by people that say, well, this thing doesn't work with the latest version of Kotlin, or this thing, this particular feature looks like it's not really fleshed out, or I'd rather have this instead of the other to make the choices more broad when you need it. Now, funnily enough, when we used to travel, I would find someone. So I live in Switzerland, and I traveled to Canada, and there was someone that quickly approached me and said, "Hey, by the way, thank you very much for the Kordamp plugin." So completely out of the blue, I didn't know this. Then I traveled to Japan some months later, and it happened again. And I don't know why there are not that many people that voice their opinion often in public forums, but they are consumers of the plugin suite, which is quite nice. And I do know there is a company in Germany that they're doing a big migration from Maven into Gradle, mostly because of the build cache and a few of the features that Gradle offer. And if this Kordamp suite did not exist, then they would be lost trying to replicate something that is Maven-like. But because Kordamp exists, they just took it and they file a bunch of issues saying, could you change this? Could you add this feature? And that's what we have done. So I can tell that the suite, well, does work for the needs that I want, that I need, but also for a couple of companies that have decided to do the migration from one build to the other.
No, we kind of past the half one mark, but has anybody got any other questions before we?
Yeah, I've got another question. Are you aware if Maven developers are working on these deficiencies that are causing people to move over to Gradle?
Some. One of the things that I liked about Gradle in the early days, when you publish your artifacts, is that the generated POM file only contains the minimum information. In Maven, well, you publish the POM as it is, and which includes your build instructions, which in my mind should not be leaked out to consumers. A few months ago, a feature called the consumer POM was added. In this way, we now can decouple what is published to consumers and what is needed for you to build your project. This is still in the Maven 4 POM model, so there are no changes to the syntax. It's just what the Maven Build Tool will publish. It will just it will grab what are the minimum elements for publication for your consumers, and that's it. In Maven 5 is where the Maven team has a schedule for changing the POM syntax into Maven Model 5. When that happens, is where it's very likely we're going to see a big break within the syntax used for building and a syntax used for publication. Invoking a command in a submodule in Maven is not as easy as you can do in Gradle, because Gradle has a graph of dependencies when it computes the task. In Maven, you have a linear invocation of the lifecycle. This is definitely not going to change in Maven 4. Don't know if it might change in Maven 5, it's still too early to tell. So in order to invoke a command in a sub-project or in a sub-module in Maven, you have to add more configuration to the root file. It is possible, but it's more verbose than it should be. The Maven team is aware of this. Because of the limitations of the POM syntax, they cannot make any real changes in this regard. And finally, the speed. Many regard Maven in terms of the speed as all right. When you start to add more projects, when you invoke many goals per project is where things go slow. The first recommendation is, if you don't have to invoke a goal, don't. Put that thing behind a profile and activate the profile when needed. And once you have done it and it's still slow, sometimes what you can do is do not include modules. So put those modules inside a profile. And when that thing is still not enough, then we definitely need to change something in the Maven Build Tool. And one thing that the team is aware of is that Gradle has inputs and outputs. You can cache those inputs and outputs to make invocations faster. That's something that they are aware of and they might be working for in latest versions of Maven, Maven 4. And there is another team in Red Hat that has created something called the Maven Daemon, which is kind of what we have with Gradle, with a background JVM invoking Maven whenever you need it and a Maven client.
Thank you.
I've got a question. Hi, Andres.
Hi, John.
Hi. One of the issues I had switching from a Maven project to Gradle, probably about 18 months ago now, was the loss or the lack of an optional flag. Does Kordamp provide anything along those lines so you can declare some dependencies that are optional?
Yes. So
excellent.
Yes, we have, it's not an optional configuration. So Nebula plugins from Netflix offered this close to 10 years ago. And the Spring Boot plugin also offers an option for this, and Kordamp does it as well. And again, this feature was requested by that German company that's doing the migration from Maven to Gradle because they find it useful.
Excellent. Thank you.
Right. So we try, in Kordamp, we try to look at those Maven features that make sense to put into Gradle. In such regard, for example, if you ever find Maven profiles to be useful, you can have profiles in Gradle because there is a profiles plugin for Gradle. That's why we brought the inline plugin, so you can invoke any plugin on the command line. That's why we have summary reports, which, by the way, are customizable. You can hook in your summary report if you want to. You can collect all the information that you want from the build, and then just do whatever you want with that data. Right now, we're just outputting at the end what is the summary of the timings within the invocations of each project and each task.
Excellent. So I've got maybe one final question just to satisfy my curiosity, really. Where does the name Kordamp come from? It's quite an interesting name, and I've just been wondering.
So this harkens back from, how long has it been? It's almost 30 years ago. From my days at college, we had a group, we have a team of friends working on projects, and we're using C and C++. And very likely our projects will crash often and will generate a Kordamp file. And then we decided to name our team Kordamp. It's just another way to write down Kordamp.
Fair enough. Cool. Thanks for that. Great. Well, yeah, I think we had a good session there. We imagine people are needing to get back to work and things now. So thank you, Andres, for joining us today. It was really, really interesting. It's something I'm definitely going to have a little play around and explore. Yeah, thanks for your time, and thanks for everybody for joining.
Yeah, thank you, everybody, again. I'm quite happy to be with you once again online. Hopefully, there will be a time where we can meet face-to-face and at your local user group.
Yeah, let's hope so. Let's hope it's not too far away. Brilliant. Thanks, everyone, and catch you all again soon. Cheers.
Thank you, everybody. Goodbye.
Thank you.
Cheers. Bye.